Um, we went through the basic mechanics of matrix multiplication and the so-called standard view of that, which is rows into columns. Um, I won't go through that again. Remember, each one of these elements of the resulting product is the computational equivalent of a dot product. And that's really why I defined dot product when I covered vectors, because it was just going to come up in matrix multiplication. We didn't really need to cover it for vectors explicitly. Um, Now I want to get into about four other views of matrix multiplication. And I'm going to go through it quickly because if you really want to understand this, you probably ought to pause on each chart I'm going to show and you just think about it. So this second view, we could call it a column view. Remember when we did this before, we multiplied a matrix times a column vector? You could view it as a linear combination of the column vectors of A. Remember that? Well, now B can just have more columns. So each column of the resulting product could be viewed as a linear combination of these column vectors of A. Each one of we already told you how to multiply a matrix times a column vector. That's what each one of these guys are. The result was a vector, a column vector. So each one of these guys is whoa, what was that? Oh no. Each one of these guys is a column vector, just like we already went through. That's the second view. The third view. Remember, a row of C comes only from the corresponding row of A. That row of A times B, it's a linear combination of the rows of B. So I can view a particular row of C as a linear combination of the rows of B. Think that one through. Fourth view. It's a sum of a bunch of full-size matrices. Here I've got I've got a 3 by 2 and a 2 by 2. I'll end up with a 3 by 2. I can take the first column of A times the first row of B, and then plus the second column of A times the second row of B. If I had bigger matrices, I would keep doing that. It's a total of n. I keep doing it. Let's see, a column K of A times row K of B, for K equals 1 to n, however many columns of A you add. So here's that case. The first column of A times the first row of C, second column of A times the second row of B. Those two could be multiplied. I end up adding them together. That's another way to view it. Remember, we're not necessarily talking about other good ways to actually compute it. It's ways to view these things. It takes a while for this to sink in, and like I said, it hasn't totally sunk in with me, but to really get slick at this stuff. And this final view, you could divide up your A and B into blocks. So each of these A with a subscript it's actually sort of a mini matrix. Same with the B's. Then you could multiply the whole thing just same way you do a matrix. This guy will be A1, B1 plus A2, B3 for this top thing here, assuming all these blocks are a compatible size. And actually, a lot of the previous views, maybe all of them, were sort of particular cases of this block view, depending on how you do the blocks. This actually will come in handy multiple times later in the course. Okay, that's as far as I'm going to go with matrix multiplication. This stuff has to sink in. I'll just stop it there.